Hey guys, welcome to your first flipped lesson. Today we're going to be learning section 5.6, finding rational zeros. So far, you've learned how to find all the real zeros of a function if I have given you a zero or a factor to get you started. You've been using synthetic division to divide that factor out, find the remaining function, and then factor it or use the quadratic formula to find the other zeros. Now, you're going to be able to find all the real zeros of a polynomial function on your own without me having to get you started at all. The key to this is the rational zeros theorem you see here. It says if f of x equals the polynomial shown, has integer coefficients, then every rational zero of f has the following form. P over q, where p are the factors of the constant term and q are the factors of the leading coefficient. So we can use this theorem, as we will right now in example 1, to list the possible rational zeros of a function using the rational zero theorem. Here our function is f of x equals 4x to the fourth minus x to the third minus 3x squared plus 9x minus 10. So what we need are all the ratios of the factors of the constant term over the factors of the leading coefficient. So let's list those out first. We'll list out the factors of the constant term. The constant term in this problem is negative 10. So we're going to list out all the factors of negative 10. And they are plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Be sure when you're using this theorem to remember the positive and negative factors. Next, we're going to list out the factors of the leading coefficient. The leading coefficient in this problem is 4. So the factors of the leading coefficient are plus or minus 1, plus or minus 2, and plus or minus 4. We've listed both parts that we need separately, and in the next step we're going to put it together to see all the possible combinations of these factors, all the possible rational zeros. So we're going to list out these possible rational zeros. Okay, so you're going to do each of the factors of the constant term with each of the factors of the leading coefficient. What I mean is you'll do plus or minus 1 over plus or minus 1. Plus or minus 1 over plus or minus 2. Plus or minus 1 over plus or minus 4. That is all for the first factor of the constant term. We're going to do the same thing now with the next three factors. So 2 over 1, 2 over 2, 2 over 4. Then with 5, 5 over 1, 5 over 2, 5 over 4. Then with 10, 10 over 1, 10 over 2, and 10 over 4. Sorry, I went off the screen a little bit here. So here are all the possible rational zeros, but as you all know, not all of these fractions are simplified, and some of them, when we simplify them, will actually be the same. So you want to write a simplified list of the possible rational zeros. So our simplified list, which would be our final answer for this problem, 1 over 1 reduces to 1. 1 over 2 we will leave as 1/2. 1 over 4 does not reduce. 2 over 1 we can write as 2. 2 over 2 is 1, which we already have here, so you do not need to write it again. 2 over 4 is 1/2. Don't need to write that again. 5 over 1. 5 over 2 is a new one. 5 over 4. 10 over 1. 10 over 2 is 5, which we already have. 10 over 4 is 5/2, which we already have. So this is our complete list. And we have 1, 2, 3, 4, 5, 6, 7, 8 times 2 because the positive and negative. 16 possible rational zeros for this function. That's it for this problem. In the next problem, we will be going a step further and actually seeing which ones of these possible rational zeros are one of the real zeros of the function. Before we do that, I just want to let you all know that my favorite sports team is the New York Mets, and baseball is my favorite sport. I want you, on a sheet of paper, to write down your favorite sport to watch and your favorite team, and bring it with you to class on Monday. Okay, moving on to the next piece. The list we did in the last problem only gives us the possible zeros. In order to find the actual zeros, we must test values from this list. And these are the steps we're going to follow to do this. You're going to list the possible zeros. Then you're going to use synthetic division to evaluate the polynomial at each possible rational zero. When the remainder is 0, note the quotient you have obtained. And you'll know that the value you divided by is one of the zeros or x-intercepts of the function. You're going to then repeat steps 1 and 2 for the quotient. Stop when you reach a quotient that is quadratic or factors easily, and use the quadratic formula or factoring to find remaining zeros. So here, in example 2, we're going to do the whole thing. We are going to find all the zeros, real zeros, of this function, p of x equals x to the 4th minus 5x to the 3rd minus 5x squared plus 23x plus 10 from scratch. We're not given anything to get started with. What we will get started with is, just like in the last example, we are going to list the possible rational zeros. This one actually is a little easier because our leading coefficient is 1, which makes things much nicer. To do that again, we'll list the factors of the constant and the factors of the leading coefficient. Factors of the constant is 10, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Factors of the leading coefficient, and this is why things are nice, is because it's just 1. So our possible rational zeros are just plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. So we still have a bunch. We have 8 possible rational zeros, but this is better than the last problem. In this one, we're going to actually now test to see which of these are actually zeros using synthetic division. Okay, so we are going to start, I'm going to start with positive 1. I'm going to do synthetic division how we've been doing it and see if my remainder is a 0. So I do 1, negative 5, 23, and 10. 1, 1, negative 4, negative 4, negative 9, negative 9, 14, 14, 24. This is not equal to 0, So 1 is out of the running. It cannot be a 0 for this polynomial. The next one is, I'm going to go through and try all the positive ones first. Let's try positive 2, and then we can go back later and try the negatives. So that didn't work. I'm going to start over. 1, -5, -5, 23, 10. 1, 2, -3, -6, -11, -22, 1, 2, 12, also not a 0. No good. I'm going to try positive 5. 5, 1, -5, -5, 23, 10, 1, 5, 0, 0, -5, -25, -2, -10, 0. Ta-da! We have our first 0. Without being told, we have now found that 5 is a 0 of this polynomial. And now we know that when we divide out x minus 5, which must be a factor, we are left with the following. So we can rewrite our polynomial a little simpler as p of x equals x minus 5, and then we're left with x cubed minus 5x minus 2. Unfortunately for us, we still can't factor this, so we now have to keep testing to see which of the other possible zeros will also work. So we're going to go through from here, and you can see this process sometimes takes quite some time. Next, I'm going to try my last positive rational possible 0, and we're going to do that with the quotient. So now I'm going to test 10, but I'm testing it with the quotient I found when I found a 0. So 10 is here, and then I have 1, 0, -5, -2. 1, 10, 10, 100, 95, 950, 948. Sorry, I'm off the screen a little here. Definitely not a 0. So we have to keep going. All the positives are either out or 5 was our 0. Let's try the negatives now. I'm going to start with -1. And again, I'm going to continue to use that quotient that I found rather than the original function. So I'm going to try -1, -1. Again with the quotient 1, 0, -5, -2. We get 1, -1, -1, 1, -4, 4, 2. -1 is not a 0. Moving on to -2. Again, still from that quotient. 1, 0, -5, -2. We get 1, -2, -2, 4, -1, 2, 0. And we finally have gotten another 0. -2 is also 0, as well as 5. So now our polynomial, before this step, we had broken it down to p of x equals x minus 5 times x cubed minus 5x minus 2. Now we divided x plus 2 out, so we have x minus 5 times x plus 2, and we are left with what we see here, x squared minus 2x minus 1. And we are going to see if this can factor, which cannot. So this problem gets longer. How do we find our other zeros? We're going to use the quadratic formula with this part. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Going off the screen again. So we get 2 plus or minus the square root of 4 plus 4 all over 2. Okay, and we get 2 plus or minus 2 radical 2 all over 2, which gives us 1 plus or minus 2, 1 plus or minus 1 radical 2 are our other zeros. So we have 1 plus radical 2, 1 minus radical 2, and then we have 5 and negative 2 as our 4 zeros. So we would list them out. X equals 5, x equals negative 2, x equals 1 plus radical 2, and x equals 1 minus radical 2. This is our final answer. The problem asks us to find all the zeros. We have factored it completely using a combination of skills, our rational zero theorem from today, along with our old stuff, the synthetic division. Note that these two are not rational zeros, so they weren't in our original list. The rational zeros theorem only lists the possible rational zeros, which we know are numbers that can be written as fractions. So that's it for this lesson. In addition to writing down your favorite sports team for me, I want you to try one of these on your own and bring it in with you as your homework assignment for Monday. You're going to factor the polynomial 2x to the third plus x squared minus 13x plus 6 and find all of its zeros. So remember to get started by listing the possible rational zeros, then testing all of them using synthetic division until you get down to a quadratic, and then you can use the quadratic formula, or if you're lucky, maybe you can factor. Have a great weekend. See you Monday.